Hello, this is Mrs. Ward, and I am going to go over the practice worksheet for section 2.2, which is using those rules to find the derivative. So number one is asking you to find the derivative of the function. Sometimes you're going to want to rewrite the function before you find the derivative to make life a little bit easier. So for A, I'm going to rewrite this 1 over x to the 7th as x to the negative 7th. Then I'm going to multiply by the power, reduce the power by 1. Remember, your final answer has to be written with positive exponents. So my final answer is going to be negative 7 over x to the 8th. Number 2, or B, I'm going to rewrite as x to the 1/3 power. Now I'm going to multiply by the power, reduce the power by 1, and finally rewrite as a positive exponent. And C, remember pi is a constant. So when I go to take the derivative of this, I'm going to do 4/3 pi and then multiply by the power, which I'm going to multiply by 3 and reduce the power by 1. Here the 3's will simplify, and I'm left with 4 pi r squared, and that's the derivative. Okay, moving on to D, I don't need to rewrite that. That is x to the negative 2/5. So to find the derivative of that, I'm going to do negative 2/5 times x, reduce that power by 1, so that's going to be negative 7/5. And now I'm going to write it as a positive exponent, so I'm going to have negative 2 over 5x to the 7/5. E, as easy as it can get. 8x to the 7th. Nothing really to say about that one. All right, I'm going to do 5, 6 times 3, reduce that power by 1, so that'll be to the negative 1/6 power. When I multiply, I'm going to end up with 5 halves x to the negative 1/6. So then when I rewrite it, I'm going to have 5 over 2 times x to the 1/6 power. Okay, moving on to the next one. It says find the derivative of the function. So when I have terms, remember I'm going term by term by term. So the derivative of negative 2t is going to be negative 4t. The derivative of 3t is just 3. The derivative of 6 will be 0, so I'm not going to write anything. When I go to do B, since I'm dividing by x, I have to rewrite that. So in order to rewrite that, I'm going to divide every single term by x. So I'm going to let me clean that up first before I take the derivative. So this will be x plus 4 plus 3x to the negative 1. Now taking the derivative, I'm going to have 1 plus 0, I'm not going to write it, minus, because negative 1 times 3 will be a negative 3x to negative 2. Finally, write it with positive exponents, and I'm going to have 1 minus 3 over x squared. C is different than B because C, I'm dividing by a constant. So to do that, I am just going to think of 1/4 outside of this entire parenthesis. And then I'm going to take derivative term by term and finally distribute that negative 1/4 back in. So I am going to leave that 1/4 out here. The derivative of 12x to the 12th will be 12x to the 11th minus 9 times 2 will be 18x to the 8th. And then negative 7 times 5 will be negative 35x to the negative 8th. Now I'm going to distribute that 1/4 back. And you have options. Like one option, you can just do 12x to the 11th minus 18x to the 8th minus 35x to the negative 8th and put that all over 4, but then you have that negative exponent. So I don't like that. So to be perfectly honest, I'm not going to do that. I'm going to distribute the 1/4 term by term. So I'm going to have 3x to the 11th minus 9 halves x to the 8th minus 35 over 4x to the 8th. And that makes me happy because all my exponents are positive. Number 3, find the slope of the graph of the function at the indicated points. So to find the slope of the graph, you're going to find the tangent. You're going to find the slope of the tangent line, which means you're going to find the derivative. So to find the derivative of negative 1/2 would be 0, and I'll write that if I must. And then to find the derivative of 7/5 x to the third, I'm going to take 3 times 7/5. That'll be 21/5. Reduce the power by 1, so 21/5 x squared. I want to find the derivative when x is equal to 0, so I'm going to substitute a 0 into that, so 21/5 times 0 squared, which is going to be 0. So it just wants the slope at the end, so the slope is going to be 0, and that's all I have to do for that one. For B, doing the same thing, I want to find the slope of the function at the indicated point, so I'm going to find the derivative. Before I do that, I'm going to rewrite that as x to the 1/2 power. So when I find the derivative, that's going to be 1 plus 1/2 x to negative 1/2 power, writing it with positive exponents 2 over x to the 1/2. So there's my derivative. And now it wants me to find the derivative at the indicated point, which was x is equal to 1. So substituting 1 in. So 1 to the 1/2 power would be 1 times 2. So this is going to be 1 plus 1/2, and my final answer is going to be 3/2. So that is my slope or my derivative at 1, however you want to write it. Okay, number 4, you're asked to find the derivative, but before I can find the derivative, since I'm dividing by that variable, I have to rewrite it. So to rewrite it, I am going to divide each term by that x. So I'm going to write x to the third divided by x squared minus 3x squared divided by x squared plus 4 divided by x squared. So the function is actually going to be x minus 3, and then I'm going to write plus 4x to the negative 2. Now I'm going to go ahead and find the derivative term by term. So this will be 1. The derivative of 3 will be 0. And then I'll take 4 times negative 2, which will be negative 8x to the negative third. And rewriting that with no negative exponents will be 1 minus 8 over x to the third. Number 5, determine the points, if any, at which the graph of the function has a horizontal tangent line. So I am going to take this and find the derivative. So that's going to be 1 minus sine of x. I am going to add, I'm going to set the derivative equal to 0 first. So I'm going to say 0 is equal to 1 minus sine of x. Then I am going to add sine of x to both sides. So sine of x is equal to 1. And now I'm asking myself, when is the sine of x equal to 1 with one lap around the unit circle? And that's going to happen at pi over 2. So my answer is going to be x is equal to pi over 2. Number 6, find an equation of a tangent line to the graph of the function through the point x0, y0, not on the graph, to the point of tangency xy on the graph. Solve the equation. So this is the point that is not on the graph, that is on the tangent line to the graph. So I went ahead and I graphed this. So this is what I have, is I have this parabola. So I'm just going to sketch that so you can see what I'm doing here. So I have this parabola, and then I have this point here. I'm going to sketch my tangent line first. Let's say I have a tangent line here. I have this point here, 2, 0, that's on the graph. I have this other point here, xy, that's on both graphs. It's on the tangent line and it's on the function, because this is my f of x, which if I want to write that, that's 3x squared plus 4x plus 7. So the first thing I'm going to do is I know at this point, the graph slope and the tangent line slope are the same. So I'm going to function on the slopes right now. So the first thing I'm going to do is find the equation for the slope. So I'm going to take the derivative of f of x and get 6x plus 4. Then I'm going to use, this is just telling you the slope of a line, the difference of the y's over the difference of the x's. And they're telling you that it's equal to the derivative of f, so it's going to equal this. So let's write that. Okay, I'll follow their order. So they did 0 minus y over 2 minus x, and that is going to equal that. But before I do that, I chose to multiply both the numerator and the denominator by -1. I'm multiplying by 1. So I can write y is equal to x minus 2. I'm going to set that equal to the derivative, which is 6x plus 4. I'm going to multiply both sides by this x minus 2. And when I do that, I'm going to have y is equal to, foiling out, I'm going to get 6x squared minus 8x minus 8. So that's the equation of the line, well actually it's a parabola, the equation of a parabola that meets the criteria of having this point in common with the slope of this graph. So basically what's happening is I must have another parabola that goes like this somehow, not quite sure how it goes. So I probably have another point of tangency too. So I should figure out, but this at this point here, these two are both equal to y. Y is equal to 6x squared minus 8x minus x. And y, because f of x is another way of saying y, is equal to this. So I'm going to set those two functions equal to each other. So I'm going to take that 3x squared plus 4x plus 7. I'm going to set that equal to 6x squared minus 8x minus 8, because I'm finding the place where those two equations intersect. So I'm solving a system basically. So this will be 3x squared minus 12x minus 15. I'm going to product sum, so I'm going to do myself a favor and divide by 3. That should make life a little bit easier. So I'm going to have x minus 5, x plus 1. So x is equal to 5 and x is equal to -1. So this point here is probably -1 something, and then this point over here is 5 something. Well, it wants me to write the equation of the tangent line, so I need to know the y values. So I can substitute that -1 and 5 either into the original equation or to the equation that I came up with, that 6x squared, to find the y's. I chose to substitute back into the original equation, so I'm going to do f of -1. And that is going to equal 3 times -1 squared plus 4 times -1 plus 7. And when I do that, I get 6. So this ordered pair is -1, 6. I do the same thing for 5. So let's do that over here. F of 5 is equal to 3 times 5 squared plus 4 times 5 plus 7. And when I do that, I get 102. So that point's going to be way up there. That's going to be 102. So now I have 2 points on the line. So I can find the slope by doing the difference of the y's over the difference of the x's. I could do that, but that seems so algebra 1 to me. I'm going to use the derivative and use the little calculus trick. So I'm going to find the derivative at this point. So this will be -1, the derivative. So this will be 6 times -1 plus 4. And I get a slope of -2. And it should make sense to you that this slope is going to be way different than this slope. I hope that makes sense. So I'm going to find the slope here. So the slope at 5 is going to be 6 times 5 plus 4, which is equal to 34. And both of those make sense. This one, negative, makes sense. This one, positive, makes sense. Larger, makes sense because it's a steeper line. Now let's write the equation. I'm a slope-intercept person, so we're going to zoom this out here. I'm going to do y minus 6 is equal to my slope times x minus the -1, so x plus 1. And that final equation is going to be y is equal to a -2x plus 4, so that's one equation of a tangent line. And then the other one is going to be f, oh no, sorry. Going to be y minus 102 is equal to 34 times x minus 5. And when I do that, I get 34x minus 68. So that's going to be the other one. So what I did is I went on my calculator, and here's the original equation. I just wanted to check to make sure that these answers made sense. So I graphed both of those lines. So here's the first one, that 34x minus 68. Can't really see it, but I'll get it in a second. And then here's the other one, the -2x plus 4. So here I can see that that definitely looks like a tangent line. if I zoom out here a little bit, zoom out, and let's go up here, way up here, and then if I want to zoom in at this point, zoom in, it does look like it's going to be a tangent line there too. So that's the way I can check on my calculator and make sure it makes sense. I think drawing the picture really helps you see what you're doing. All right, moving on to the next one. Number 7, it says find the average rate of change. So the average rate of change is taking me back to finding the slope of the secant line. So in order to find the slope of the secant line, I am going to find f of 1. And when I do that, I'm going to put f of 1 in here. So 1 squared plus 3 times 1 minus 1. And that ends up equaling 1, 4, 3. That ends up equaling 3. And then I'm going to find f of 2, which would be 3 squared plus 3 times 3 minus 1. So that will be 17. So I'm going to do the difference of my y, so 17 minus 3, over the difference of my x's, which is 3 minus 1. And when I do that, I get 14 over 2, which is 7. So that's my average rate of change. Then it says compare this average rate of change to the instantaneous rate of change at the endpoints. Instantaneous rate of change means the derivative. So I'm going to find the derivative function of that formula. So that will be 2x plus 3. And I'm going to do at the endpoints, so at 1. And when I do that, I get 5. And when I do 3, I get 9. So that's comparing the difference of instantaneous rate of change with my average. Part B is doing the same thing, except for it's with a trig function. So I am going to do the average rate of change. So I'm going to find f of 0. So the cosine of 0 is going to be 1. Then I'm going to do f of pi over 3. So that's going to be the cosine of pi over 3, which is equal to 1/2. So I'm going to do 1 minus 1/2, the difference of my y's over the difference of my x's. And when I do that, I get positive 1/2 over a negative pi over 3. Multiplying by the reciprocal, I end up with a negative 3 over 2 pi. So that's the average rate of change between the endpoints. Now I'm going to find the instantaneous rate of change. So I'm going to find the derivative of cosine, which is negative sine. So I'm going to find the derivative at 0, which is going to be the sine of 0, which is 0. And then I am going to find the derivative at pi over 3. So that's the opposite of the sine of pi over 3, which will be a negative square root of 3 over 2. Okay, 8. Write the equation of the tangent line at the given point. So it gives me a point. So I'm going to find the derivative, find the slope of the tangent line. So I'm going to have 6x minus 8x plus 5, and then that 7, the derivative is 0. I want to find the slope when x is equal to 3. So I'm substituting in 3, and when I do that, I end up with 35. So that's the slope of my line. Then I'm going to do point slopes. I'm going to say y minus 26 is equal to my slope times x minus 3. And when I work that out, I get y is equal to 35x minus 79. B, same thing. I'm going to find the derivative. So the derivative is going to be 2 minus the sine of x. And now I want to find the derivative at pi over 6. So I'm going to have 2 minus the sine of pi over 6. While the sine of pi over 6 is 1/2, so I end up with a slope of 3/2. Now I want to find the equation of the tangent line. So there's my slope, there's my xy. So I'm going to do y minus my y, which is pi over 3 plus the square root of 3 over 2. And I'm going to leave that in parentheses because I have to distribute the negative sign. And it's just easier for me to leave in parentheses. Then my slope times x minus pi over 6. So when I do this, I'm going to have 3x over 2 minus, and then the 3's will simplify, and I'm left with pi over 4. And then I'm going to add this whole quantity, this pi over 3 plus the square root of 3 over 2 to both sides. So I'm going to do that now, pi over 3 plus the square root of 3 over 2. And when I do that, I get y is equal to 3 halves x, and then negative pi over 4 plus pi over 3 will be a positive pi over 12 plus the square root of 3 over 2. It's not pretty, but it is the slope of the tangent line. So I want to show you that graphing. So give me a second to pull up my calculator. So to check this, because it was kind of a funky answer, I put the original function in, which is this 2x plus the cosine of x, and I have this graph. Then in the next one, I put in the equation of the tangent line that I got, which is this. And if I graph that, I can see that it does intersect that point. And if I hit menu, trace, graph trace, and I put in pi over 6, just to see where pi over 6 would be on this graph. It's going to put my little spider there, and it looks like it's tangent there. If I wanted to investigate more, I could do my window, and I could zoom in on that point, and I can see that it does appear to be tangent at that point. So it appears that I came up with the right tangent line. So you can use your calculator to check. You could have also used your calculator to find the derivative at a point for that 2x plus cosine x. You could have found it at the point pi over 6, and you would have gotten the 3 halves. So at least you would have known your slope was right as well. So that is all, and I hope this helps, and we will see you next time.